channel. So welcome back to my channel, guys. So today we're going to discuss the same book, University Physics with Modern Physics Volume 1, 14th edition, and we're currently at chapter 14 entitled Periodic Motion. So I'm going to give you 3 problems and we're going to tackle them one by one and we're going to solve them step by step. So I hope that you will follow through with the video and learn a lot with this video. So let's start with the first problem. Problem number 1. The tip of a tuning fork goes through 400 complete vibrations in 0.550 seconds. Find the angular frequency and the period of the motion. So the problem is requiring that we should solve the angular frequency and the period of the motion. So we know that the formula for the angular frequency is 2 pi divided by the period. But since we cannot solve the angular frequency because we don't have the period, but we know that the formula for the period would be time divided by the frequency. And we're given, the problem gives us time and frequency, so we have to solve the period, which would be t, which stands for period, is equals to time, which is 0.550 seconds, divided by the frequency, which is 400 complete vibrations, so divided by 400, and it would be equal to 1.38 times 10 raised to negative 3. So that is your period. So now that we have solved for the period, we can finally get the angular frequency. So the angular frequency is equals to 2 pi divided by the period of the motion, which is 1.38 times 10 raised to negative 3, and we would get 4.55 times 10 raised to 3, or 4.55 times 10 cubed radians per second. That's the unit of the angular frequency in radians. So let's proceed to problem number 2. A small block is attached to an ideal spring and is moving in simple harmonic motion. So SHM stands for simple harmonic motion on a horizontal frictionless surface. When the block is at x is equals to 0.310 meters, the acceleration of the block is negative 5.96 meters per second squared. What is the frequency of the motion? So first, let's list down the given in the problem, which is x, which is the distance. So x is equals to 0.300 meters. So the block is at 0.310 meters. And for the acceleration of the block, it's negative 5.96 meters per second squared. So the problem is asking for the frequency of the motion. And we know that the formula for the frequency in SHM terms is equals to 1 divided by 2 pi multiplied by k divided by the mass. And we're actually looking for the k over m variable in the formula, but it's not given in the problem. But we know that force is equals to kx, and force is also equals to mass times acceleration. So using that formula, we would get k divided by m is equals to negative acceleration divided by the distance. So we know that k over m is equals to acceleration over the distance. So using that formula that we have derived, we would get the acceleration, which is negative 5.96 meters per second squared as given in the problem, divided by the distance, which is 0.310 meters. So the negative sign on the side would be useful for when we get the, because k over m is square root in the formula, so we have to get the root of k over m, and there is no square root for a negative number, so that negative sign is for that. So typing that into the calculator, we would get k over m is equals to 19.23 seconds squared, or second raised to negative 2, because it would be blank per second. So after getting that value, we just plug it into the formula, which is frequency is equals to 1 divided by 2 pi multiplied by k over m, and k over m is equals to 19.23. And we would get 0.70 hertz. So the frequency of the motion is 0.70 hertz. So that's the unit of frequency, which is hertz. For our last problem, a 2 kilogram frictionless block attached to an ideal spring with force constant 350 newtons per meters is undergoing simple harmonic motion, or SHM. When the block has displacement positive 0.200 meters, it is moving in the negative x direction with a speed of 4.00 meters per second. So we have to find the problem is asking for 3 variables, which is the amplitude of the motion for letter A, and for letter B, the block's maximum acceleration, and lastly, for letter C, the maximum force the spring exerts on the block. So first, the amplitude of the motion. So we list down the given first, so we know what equation we should use. So we have the mass, which is 2 kilograms, and for the force constant, it would be 315 newtons per meters. K is also called force constant. And for x, or the displacement, it would be positive 0.200 meters. And for the velocity of the block, it would be 4.00 meters per second. So the problem is asking for the amplitude of the motion. So we have to find the amplitude of the motion. We know that the formula for the velocity in simple harmonic motion terms, V is equals to the force constant divided by the mass. So square root of the quantity of the force constant divided by the mass multiplied by the square root of the amplitude squared minus the distance squared. So we actually have to use this formula to get the amplitude of the motion. So we isolate A, which is the amplitude of the motion, in this using this velocity formula. So using algebra, we would get amplitude, or A, is equals to square root of the quantity of mass times velocity squared divided by the force constant plus the distance squared, or x squared. So plugging in the values, A is equals to the square root of 2 kilograms multiplied by the velocity, which is 4.00 meters per second, and you have to square that, divided by the force constant, which has a value of 315 newtons per meters, plus the distance, or the displacement, is 0.200 squared. So solving that, we would get 0.38 meters. So that is the amplitude of the motion. And for letter B, we have to solve for the block's maximum acceleration. We know that the formula for the maximum acceleration would be equal to negative k, or force constant, divided by the mass multiplied by the displacement. And we know that the displacement would be equal to the negative amplitude. So with this, we change the x into the negative amplitude in the formula. So we would get acceleration, or maximum acceleration, is equals to negative k over m multiplied by the negative amplitude. And negative times negative would be positive. So the negative signs are cancelled out. So plugging in the given in the formula, we would get 350 newtons per meters, which is the force constant, divided by the mass, which is 2.0 kilograms, multiplied by the amplitude, which we solved in the previous slide. So we would get 0.38 meters. So solving that, we would get 59.85 meters per second squared. So that is the maximum acceleration of the block. And lastly, for the maximum force the spring exerts on the block. So we would use the formula, or force formula. So maximum force is equals to negative k, or the force constant, multiplied by the displacement. And from the previous slide, we know that x would be equal to the negative amplitude. And with that, so they are both negative, and negative times negative is positive, so the signs cancel out. So maximum force is equals to 315 multiplied by the amplitude, 0.38 meters. And we would get 119.7 newtons. So that is for problem number 3. So thank you for watching this video. I hope you learned a lot about periodic motion.